Then we want to look at matrices. And first of all, we want to look at the notation of a matrix. Now, a matrix A can also be written as Aij, where I represents the number of rows and J represents the number of columns. I by J would represent the order of the matrix. So in terms of writing on the elements, remember we have I rows and J columns. So our matrix A this is really in terms of rows and columns, and elements it's A11 because the element in the first row first column, element in the first row second column, up to the element in the first row but J's column. Then we go A21, that's the element in the second row first column, A22, element in the second row second column, up to the element in the second row but G column. And then we extend this now to the element in the ith row but first column, element in the ith row but second column, up to element in the ith row and G column. Now we look at the transpose of a matrix. Now the transpose of a matrix is found by interchanging the rows and columns of the matrix. So let's say we have a matrix A which is equal to Aij, then the transpose of the matrix A transpose A raised to the power of t is really equal to Aj. So we are interchanging the rows and the columns. So let's now look at an example. So if we have matrix A which is equal to 1, 2, 3, 4, 5, 6, we have 2 rows and 3 columns. The transpose of A will now have 3 rows and 2 columns. So we're interchanging the rows. So the first row becomes the first column and the second row becomes the second column. Let's say we have B now. B it's 1 minus 1, 1, 0, 2, 4 and 0, 0, 3. Then B transpose, your first row becomes the first column. So write as 1, negative 1, 1, 0, 2, 4 and 0, 0, 3. Now let us look at the properties of the transpose of a matrix. If A and B are square matrices, now square matrices simply means that they have the same number of rows and the same number of columns. Then A transpose or the transpose of A transpose should give us A. 2. A constant K multiplied by A transpose is K times the transpose of A. The A plus B to be transposed is A transpose plus B transpose. A, the product of two matrices AB transpose is equal to B transpose, A transpose. And then the last two properties are very significant if you're dealing with vectors in 3 dimensions and vector spaces. If A transpose is equal to A, the matrix is said to be symmetric. And if A transpose is equal to negative A, the matrix is said to be skew symmetric.